All right, the SD Access Challenge. I know some of y'all are really excited about this because it's hard to get real SD Access experience out there. Now, here's the thing: if you're new to SD Access, if you haven't watched our content on CBT Nuggets, this part's going to be pretty challenging because the real challenge here is that you understand the design of SD Access and the key terms. Like, how does an interior border node differ from a default border node? And how would you configure their fusion routers that are pairing up to them based on their behavior in the first place? That's the real challenge here. So in this video, we're actually going to be configuring fusion routers as part of the challenge, but the understanding is, how does a interior border node handle the connection to the fusion router and versus a default border node? Trust me, it's going to be really cool if you've watched our content. Let's get going. All right, time for DNA Center. I've got my DNA Center shirt on, so you know I'm fired up about this because I really love all of the new things that are coming on the new CCIE. It's not just the routing and switching anymore, which is, cool. It's fun, and sometimes I limp through it, as you've been able to see. But the software-defined networking and the automation, that's really my sweet spot. And if you know me, if you follow me at all, you know that, Python, automation, DNA Center, and SD-WAN, that's where I really like this. So time to jump into SD Access. First thing, let's bring up the tasks right now so we can see SD Access. So you can see here, there's like 3 tasks, and here's the kicker. If you haven't watched our content on CBT Nuggets, if SD Access is even a little shaky to you, you're not going to understand any of this. The expectation in this case is that you understand what a border node does, what an edge node does, and what a fusion router does, and how you would deploy them in the real world. So here I'm looking at, border 1 should behave as an internal border. Border 2 should behave as a default node. And while the configuration of those devices does behave like that, how you handle the route leaking on the fusion router matters. So to set up what's going on here, let's bring up these devices. I want to show you, this is actually really cool. We'll bring up R69. Oop, here we go. I think we actually have to set some IP addresses on these because I just kind of fired up this lab. Here, we'll do the split screen one more time. Fusion router 1, fusion router 2, border 1, border 2. So this is really cool. I actually fired up my DNA Center lab and copied and pasted the core chunks of my SD Access fabric. So the border nodes and the edge nodes are already deployed, and that's what the task tells us. So let's bring it back up again. Yeah, so a new SD Access fabric was deployed for customer 1 bright pink site. There are 3 virtual networks participating in the fabric: IT virtual network, IoT virtual network, and HR virtual network. Check it out. If I do show run, immediately right here at the top. So again, this was all basically copied and pasted straight out of my SD Access fabric. I omitted things like certificates because that's a huge chunk of the running config, and I omitted CTS, which is Cisco TrustSec, and I omitted all of the policies because it makes just the running config absolutely gigantic. But the core routing functions, they're all there. So each virtual network, as we know, because you've studied SD Access, is a VRF. And if we look at these, like if I do show IP interface brief, there's a whole lot of addresses going on here, right? So the Lisp domains right here and the loopbacks, these IP addresses are the Anycast gateways within the environment. So when a user in the IT virtual network, let's do like show run interface loop 1021. So we can see here, this is the HR virtual network. When someone in the HR virtual network plugs into the fabric, this is going to be their gateway, 172.17.21. And that's going to be the exact same address that's on any edge device or any border device within the fabric. But those devices all still communicate between each other using VLAN interfaces or Lisp interfaces. And of course, these point-to-point links are the underlay itself. So if this is totally new to you, you probably want to spend a lot of time understanding what's about to happen here. Because the loopbacks are the Anycast gateways, whereas the VLANs are the actual border node handoffs. So the border node is going to trunk up to the fusion router. We're going to form BGP relationships based on these VLANs. And look, so let's do show run interface, let's say VLAN 3005. See this? So this is in the HR virtual network or the HR VRF, and this is in the HR VRF2. So we form our BGP relationship to the Fusion router based on the VLAN interface, but then we'll be able to share via BGP the actual IP address or the actual VRF and IP address scheme themselves. In fact, when you deploy a border node and you tell it you're a border node, here's the border handoff interface, it configures the BGP items for you already. See, I'll do section BGP. See this? So here's like the HR virtual network BGP system, and here it's expecting to peer with a remote, an eBGP relationship 65005. Our BGP ASN is 65001. It's also worth pointing out that we do have a neighbor relationship, an iBGP relationship, based on the connection to the other border router. So that's all to say that our tasks here are to configure the Fusion routers to forward traffic to and from the fabric. Border 1 should behave as an internal border node. So that means we are selectively going to be pulling routes into or leaking routes into each VRF towards the shared services block. So this would be a DNS server, a DHCP server, or an active or a domain controller. So every device within the fabric potentially needs DNS. So it would all of these VRFs still need to communicate back to one shared subnet, which is what the shared services is. So let's do that. Let's just handle this right now. Let's do border 1 to Fusion router 1. So first thing we need to do on Fusion 1, this is actually a switch under the hood, so we're going to configure it like a switch. We need to get our VLANs created. So let's do show VLAN brief. Okay, so, and if I do show IP interface brief, so we're looking at VLANs 3005 through 3008 that we need to create for sure. VLAN 3005, exit. VLAN 3006, exit. VLAN 3007, exit, and VLAN 3008, exit. So we have the VLANs created. We need to create the interface VLANs 3005. Now here's how I'm going to do this. If I look back on border 1, it tells me based on the BGP relationship. So if I look at show run interface VLAN 3005, I see this is in my HR virtual network. So now if I do show run section BGP, I'll look in my HR virtual network configuration and it tells me this is the IP address we're expecting. So I'm going to cheat a little bit and just say this is going to be the IP address. Now the other thing is I'm pretty sure, let's look, these are /30s. Now the underlay networks, I think this is pretty cool. The underlay networks, all the point-to-point links that ISIS is configured on, they're actually /31s. But the interface VLANs are /30s. So let's do IP address, paste it in, 255, 255, 255, 252. No shut. Interface VLAN 3006. So let's see what 3006 is. Show run interface VLAN 3006. There is no VRF here. So this is going to be just plain old IPv4. Show run section BGP. So I'm looking at this guy right here, 192.168.140.50. So IP address 255, 255, 255, 252. No shut. Exit. Okay. Let's do show run interface VLAN 3000. What are we on? 7. This is the IT virtual network. Show run section BGP. The IT virtual network, here it is. Right there, that one. Interface VLAN 3007. IP address right there, 255.255.255.252. No shut. Interface VLAN 3008. Let's check out what we got here. So this would leave the IoT virtual network left. So let's do this neighbor one, this guy right here. Okay, and nope, that's not gonna work. IP add 255, 255, 255, 252. No shut. Okay, so now my interfaces are up. There, I should actually be able to ping one of them because it's in the global routing table. 140, was it 53? Yeah, cool. So we've got round trip connectivity now, which is a good sign. So now we need to create the VRFs. Let's do show run section VRF. A lot of stuff happening here. Let's just grab it all. Yeah, that looks good to me. Exit out of interface configuration mode, paste in the VRFs. Now the VRFs are created. Now we need to go back into the interface VLANs here and create the actual configurations, the actual VRF assignments. So interface VLAN 3005, that was, oh, I've got to do the IP addresses again. Man, that always gets me. Okay. HR_VN. Note that the caps matters on these virtual networks, or at least in somewhere within the SD Access fabric. I'm pretty sure the caps matters. So this IoT virtual network, it's I lower O upper T. That matters. Interface VLAN 3006 was in the global routing table, so we're going to 3007. What was 3007? IT, right? Yes, IT. Okay, so this is going to be interface VLAN 3007, VRF forwarding, IT_VN. Grab that IP address from 3007 one more time. It is right here. Paste. Interface VLAN 3008, VRF forwarding, IoT_VN. Grab that IP address right here. Cool. Do ping VRF IT_virtual network 192.168.140.53. Look at that. Cool. So now we've got the VRFs all in place. We have connectivity all in place. I think we need to bring up the BGP relationships. So here's what I'm going to do that. I'm going to create a new little notepad document here. And I'm just going to script all this out basically. And I am going to just copy that and paste it. Now we're just going to adjust these. Okay. So I am going to set up, okay. Let's do this. 49, remote autonomous system, 60,000, okay. Yeah, I'm one. And this is going to be my neighbor, which is going to be Fusion 1. Who is Fusion 1? I don't think I have an IP address between me and Fusion 1, right? Show IP interface brief. I don't. So I need to do that. Let's configure some interfaces real quick. Interface Ethernet 02. Let's call this IP address 10.99.99.1.255.255.255.252. No shut. Let's do this on Fusion Router 2. And actually, let's fix this too. So I'm going to set my internal BGP relationship 10.99.99.99. What did I say it was? 2? Yeah, okay. Enable config T, interface Ethernet 02, IP address 10.99.99.2.255.255.255.252. No shut, exit. And let's look at why did it not like IP address? Ethernet 02. What? Interface Ethernet 02. Oh, because this is a switch port. Man, I know. It's the hockey puck. Okay. No switch port. IP address 10.99.99.1.255.255.255.252. No shut. Same thing over here. No switch port. Interface Ethernet 02. No switch port. Okay, cool. So those should come to life here. So now I've got this set up. Let's do this. And this. I need to have a loopback here. So let's do IP add. Let's call this like 111, 111, 111, 111, 255, 255, 255, 255. Let's do a loopback over here. Interface loopback 0. IP add 121, 121. How about something like that? 121, 121, 255, 255, 255, 255. Exit. Need to get a static route to each other's loopback address. So IP route 111, 111, 111, 111, 0000, destined for 10.99.99.1. Inconsistent mask. What do you mean inconsistent mask? Oh, it's got to be 255s. I keep thinking wildcard mask. 10.99. Come on, Cisco, you knew what I meant, man. Okay. Exit. IP route 121, 121, 121, 121, 255, 255, 255, 255. Destined for 10.99.99.2. Okay, so now we should be able to reach the other loopbacks. Let's do this. We've got the neighbor relationships now for what have I done here? This is right, but why does this guy say 10? Oh, because that's my 10.99.99.2. Okay. Okay, now into VPN v4 information. This is going to be 10.99.99.2. Let's just copy and paste this. How about we? This is my IBGP information. We're sending community information, so I'm just going to delete that out. We don't need to do any route map tagging here. Okay, so now we're doing the HR virtual network. We don't need to advertise a network here. We're just learning networks. Our neighbor relationship is going to be based on 45. And I don't need to set a weight. I don't need to alter the priority here. I do need to change the remote autonomous system. So I want to make sure that those all look good here. Yeah. Let me set this guy to right 49. Okay. So here we go. Don't need to advertise a network in IT. Set this to 53. Set this autonomous system to 65,001, 53, 53, 53. So this will bring up my eBGP relationship for the IT virtual network. I don't need to advertise. I don't have a network to advertise for any of these. This is all stuff that should be coming from the border router. So 57 and 57. Change this autonomous system. Let's delete these weights because I don't care about the weights on my fusion routers. And YOLO. All right, here come the BGP relationships. So HR, IoT, and IT. There they are. They all came up, no problem. If I do show BGP IPv4 unicast summary, I see that's my global routing table. And if I do unicast prefixes, there's the prefixes that I've learned so far. Let me back up. If I do show BGP VRF, let's do like IT underscore virtual network. Yeah, that works. So now I see that this particular device is learning 172.17 30 via the next hop of 192.168.140.53. Not showing as, it is showing as valid, not showing as best, which is interesting. If I do show IP route, VRF, IT underscore VN, is it in there? It's not in there. So that's interesting. That they advertised a route to me via an accessible next hop. So if I ping VRF IT underscore VN to 192.168.140.53, like I can reach that next hop, no problem. But it isn't installing that route for this prefix in my route table, which is peculiar. And that's something I'll probably want to investigate later. Fascinating. Okay. I wanted to look at the other ones real quick. Show BGP VRF IoT underscore VN. Okay, so those shows valid. Yeah. Yeah. Oh, look, there we go. It just took a second. After refreshing a little bit, now we've got bests. So there we go. All right, cool. Okay, now let's do, we need to bring up the eBGP relationship between Border 2 and Fusion 2. So I could pretty much almost, oh, actually, we got to bring up all the VLANs and stuff too, don't we? Okay, so the VLANs are different on every device. So if I actually do like show run section VLAN, see, these are the VLANs that I need to bring up over here. So let's go to Fusion 2. Whoop, there we go. Let's do show run interface VLAN 3001. So this is my HR. So it's going to be the exact same thing. Show run interface VLAN 3002. 3 is going to be IT. And 4 is going to be IoT. Okay, cool. So this won't be too bad. But I learned the hard way. We need to create our VRFs first. Show run section VRF. Okay, cool. Here's the VRFs, exit address family. So let's go to Fusion 2. Exit out of VLAN config, make the VRFs. Interface VLAN 3001. This was the HR virtual network, which needs to be let's just like copy this and then just change the IP address after the fact. How about that? Like that. Okay. Border 2. Let's do show. This is going to be right there. Fusion 2. Interface VLAN 3002. Oh, no shut. Interface VLAN 3002. Paste it. Change this to 34. And interface VLAN 3003. Wait, did I forget no shut again? VLAN 3002, no shut, interface VLAN 3003. There we go. Back to Border 2. So here's VLAN 3003. That's my IT. Oh, okay, yeah, we gotta forget. Don't forget VRF forwarding. That's important. Okay. This is gonna be 38. No shut. Interface VLAN 3008. Nope. 3004. And let's jump back to Border 2, get interface VLAN 3004. Fusion 2, paste it in. Cool. No shut. Okay. Uh-oh. There we go. think we're looking good now. So if I do show IP interface brief, I can do ping vrf hr_vn towards 192.168.140.29. Let's change this to IT virtual network. Make sure we got connectivity there. This is going to be 37. And let's do IoT virtual network. And that's going to be 41. Looks good. All right, so now let's bring the BGP neighbor adjacency to life. Show run section BGP. A lot to configure here. Let's fix all this stuff up here. So this is going to be 33. Let's fix our autonomous systems. 33. This is going to be my peer at 10.99.99.1. 10.99.99.1. Do not need to advertise any networks here. Don't need to advertise that. Don't need. Ooh, wait, maybe I do. Let's do this 10.99.99. So this is the default border node configuration. I don't know what this 130 is. I think that might have been something that I actually used in my configuration earlier. I'm going to keep it in there just in case. Actually, no, I'm not. This is going to be something that the border node is going to be handing me. So I'm going to delete those out. This is going to be 33. 33. I don't care about weight. This is going to be my peer at 10.99.99.1. I don't care about the route map. I'm going to fix this IP address real quick to get the community sent. Okay. This is also 10.99.99.1. 10.99.99.1. 10.99.99.1. And deleting this out. Okay, we don't need to advertise any networks. We don't need to advertise any summaries. We don't need to redistribute lists because that's all default border node configuration. We just need to configure our remote peer. 29, 29, 29. Actually, I don't care about weight. Deleting all of this stuff out because this is not stuff that I need to worry about. 37, fix the remote autonomous system. 37, 37, and do not care about weight yet again. Lastly, the IoT virtual network, same thing as before. Don't care about these items. That's all stuff for the default border node. 41, 41, fix the remote autonomous system before I blow that up. 41, and don't care about that. Grab it and YOLO. All right, let's see. There's our first neighbor adjacency. Second, third, fourth. There we go. All the neighbor adjacencies have come to life. Except one. Show IP. Show BGP IPv4 unicast. Summary. Why? Oh, why? Oh, because our... Do we configure the remote autonomous system incorrectly? We sure did. $5,005. Now that neighbor relationship should come up. I had the wrong autonomous system for my iBGP relationship to my peer over there, which it's still not coming up. Why is it not coming up? show BGP, IPv4, unicast, summary. Debug, BGP, IPv4, unicast. What do I want to debug? All of it. Connection refused by remote host. Okay. Show BGP IPv4 unicast summary. Debug BGP IPv4 unicast. Connection refused by remote host. Okay, so they can talk. They can reach each other's prefixes. Okay, let's do show run, section BGP. Let's see what we configured here. Why is this not coming to life? Okay, update source, loopback. And Fusion 2 show run, section BGP. Router BGP 65005. Address family IPv4 unicast. No. BGP aggregate timer. No. Send community both. No network statement. Do debug BGP IPv4 unicast. This is some weird tomfoolery happening here. Oh, no, because I'm duh. I'm trying to peer based on loopback addresses, and then I used our routing addresses. Okay. Let's fix this real quick. 111, 111, 111, 111. 111, 111, 111, 111. 111, 111, 111, 111. And 111, 111, 111, 111. Okay. Node neighbor 10.0.99.99.1. Remote AS 65005. Let's do this. Copy this. Address family IPv4 unicast. Paste that in. Now let's fix this on Fusion 2. Undebug all. Router. Man, these brain farts are killing me. No neighbor. Update source, loopback 0. Neighbor 111, 111. There it goes. One. Oh man, the basics. The basics. Update source, loopback 0. Okay, finally. Okay, so we got the BGPs all around the horn stood up here. So we've got BGP relationships from the border nodes to each other, the fusion nodes to each other, and between the fusion and the border nodes. Let's make one more thing come to life here. Let's bring up R69. Have I really gone through 69 nodes in this show IP interface brief? So it's expecting a peer relationship on 192.168.111. So let's make sure Fusion Router has that IP address, 192.168.111.1, 255.255.255.0. No switchboard. No shut. Nope, wrong IP address. 2. No shut. And now I'm going to actually run EIGRP. I'm just going to call this like 99. Network 192.168.111.0, 123.255. Over here on R69, I'm going to run EIGRP. That way, Fusion Router 1 receives all of the prefixes so that it can get to the shared services block, which I see off of E01. That's 192.168.110. So now if I look at the route table, I see I can reach the shared services block, 192.168.110, and that's what I need to get into my border nodes and into each VRF. So we have to perform some route leaking. So let's create all of our prefix lists and then all of our maps. So we'll call this, our first one is going to be IP prefix list. Let's call this services, and we'll say permit 192.168.110.0/24 less than or equal to 32, something like that. Let's create the next prefix list. This is where we're going to be trying to leak routes out of the VRFs into the global routing table. That way, our shared service, we can advertise them into the shared services block, and it can then get the return traffic. So let's get that going. So let's do show IP. So let's do IP prefix list. Let's start with like the HR virtual network, which I have already forgotten what that is. So let's do show IP interface brief. Do show IP interface brief. Okay, so that was going to be IP prefix list. Let's create this HR. Let's call this HR prefix. Let's say permit 192.168.140.40. What is that? 44 /30. I think that's right. Yeah, that's right. Let's now do the IT prefix, which is going to be 140.48. Yep, that's right. And then IoT prefix, which is going to be 56. Now we need to create our route maps. So I'm going to create my first one called global. This is going to identify the traffic that's going to be coming out of the global routing table, which was going to be our services prefix list. So I'm going to say permit, and I'm going to say match IP address prefix, and we call this services. Exit. I'm going to create my next route map, which is going to match the HR. So let's call this something like HR to global. How about that? It's going to be a permit, match IP address prefix, HR prefix. Exit. I'm going to create my next route map, which is going to be IT to global, permit, match IP address prefix list, IT prefix. Exit out of this. Route map was the last one. IoT to global, permit, match IP address prefix list, IoT prefix. Exit. Okay. Now let's do show run section VRFs because we need to perform the route leak. So here's how this is going to work. We're going to go first into VRF definition. Let's do HR virtual network. We're going to go into IP address family IPv4. And the first thing we need to do is we need to import that global prefix into the routing table here. So let's say import IPv4 unicast. Then the map was called, we just called global, right? Yeah, this was global, but it was all caps. And carriage return. We're now going to export to the IPv4 unicast table the HR to global. Let's make sure that was right. HR, yep, HR was capital. Okay. Now let's exit out of this and go out of this VRF. We're going to go into VRF definition. Who's next? IT underscore virtual network. Back into IP address family unicast. Perform the route leak. Import IP. This is the exact same command as before. Let's just like thumb up a few times. Okay. I can actually thumb up a few times to get to the export. We can just say IT to global, right? Scrolling up. Yep. IT to global. Cool. Exit out of that VRF. Let's go into VRF definition IoT underscore virtual network. Address family IPv4 unicast. Import global. Export IoT to global. Now this importing, this exporting, in my experience, this always takes like a long time to actually take effect. So if I did like do show IP route right now, I might not see them at all. Actually, I see HR took place. There it is. There's HR virtual network came in. So that's cool. The other thing that needs to happen, we need to leak out of there. We need to leak out the actual learned prefixes. We need to learn the client. We need to leak the client prefixes. So we need to, let's adjust these prefix lists real quick to add one more sequence. So let's do this. I'm going to say sequence 20, make something up. And now this is going to be those 172 addresses. So that was 172, what do we say? Hang on. Come on. Show IP interface brief. So 172, what do we got here? Show run interface loop 1021 is HR. And that was 172, make it up again, 1720. 1720.0, let's say /24 less than or equal to 32 or something like that. Let's now fix the IT prefix, which is going to be 172.17 something else. So let's do show run interface loopback 22. Okay, so that's 30. And now the IoT prefix, I'm going to guess, is the next one. 1023. Yep, 10. Okay. Very cool. So again, this will probably take a while for all of these routes to show up. I see the IoT virtual network made its way in. That's cool. And IT virtual network just appears to always be lagging behind for some reason. Okay, so cool. That stuff is all making its way in, which is, you know, fun. Yeah. And there we go. There's my 172.17s have now been leaked into the global routing table. Now, if I do show IP route VRF, let's say like, take a look at the HR virtual network. I don't see that that global prefix has been leaked in yet. That was going to be the one. Oh, you know why? Because this route is learned via EIGRP. And in order for route leaking to occur, it needs to have VPN v4 information, so it also has to be advertised via BGP. So let's go to router BGP 65005, advertise, go to address family IPv4 unicast, and advertise that network 192.168.110.0, mask 255.255.255.0. And now, after a few minutes, I should expect to see, there it is, right there. So we've now leaked the address out of the global prefix into the HR virtual network, and probably the rest of them too, to be honest. Let's see. Like IoT. Yeah, it's there. So now that prefix is now via BGP into those virtual networks. And if I jump down to the border node and I say show IP route HR VRF HR virtual network, we now have the internal routes participating in the correct virtual network, which means they're now in the Lisp domain. And our devices, our edge router devices, all of our edge nodes, and our clients who are accessing the fabric can now communicate internally to the shared services subnet. Sort of. There's one last thing we have to do. See, if we look at R69 here, I can do show IP route. It doesn't know about those routes. So we need to make sure that we're advertising those routes via EIGRP as well. So let's do this. Let's go to router EIGRP. What do I call this? 99, and just send everything. Send it all. So hopefully now in a few minutes, router 69 will start getting all of those routes and learning about some neat route. Well, I'm not seeing those routes up here, but the idea is that maybe we could put in a static route that points to 172.17s and get them that way. We can also, those are BGP routes, right? They are BGP routes. So I could also redistribute BGP 65005 metric gajillion delay reliability load MTU. Let's see if that does the trick. There they are. Cool. So that was the trick. We had to redistribute the BGP routes into EIGRP, and now the shared services subnet where DNS is, now they have a route back to the SD Access fabric. So our final trick now is we need to perform similar route leaking into Fusion 2, but Fusion 2 is going to be sending a default route into oh yeah, we need to undebug all. So we need to send a default route into the actual border node 2. So if I do show IP route, do I even have a default route right now? I don't. And my connection to R15 over here would be my way out to the rest of the world. So let's bring up R15 and see what its IP address is there, because I'm pretty sure I don't have an IP address set on Fusion 2. Show IP interface brief. Let's look at E01, 110.0.122. So config T, interface Ethernet 01, IP address, no switch port. It's going to get me again. IP address 10.0.122, 50, I don't care. 255.255.255.0. No shut. Exit out. IP route 0.0.0.0.0.0. 10.0.122. I'm pretty sure that's 15. Let's make sure. Yeah. Okay. So we now have a default route. Do show IP route. So what I'm going to do is I'm going to send a default route into BGP. But the real kicker here is like my default route is going to be, you know, via me. So they're going to have to know how to, like all of these other devices are going to have to know how to get to me too. And that's going to have to mean we're going to have to configure, we're going to have to advertise some things into BGP in the first place. So my default route is via 10.0.22.115. So we need to send 10.0.22.15 into BGP. So let's do this. Let's go router BGP 65005. And we're going to advertise that into the address family. We're going to advertise 10.0.122.0 mask 255.255.255.0. So that way when we send in the default route, it'll also have a valid next hop because it'll know about this particular prefix. So we need to, now that this route is in BGP, we need to leak it into the VRFs, and then we can do default information originate in each VRF. So let's do this. Let's exit out of this, and let's create our prefix list. Let's call this prefix list global permit 10.0.122.0/24. That's right. That's what I want to do. I'm just thinking through it in my head. And let's do a route map. Global permit match IP address prefix 10.0.122.0. Nope, that's not what we're doing. Match the prefix list by the name of global. Okay. So now what we're going to do is let's go into. Let's do this now. Let's leak that route into each of those VRFs. So let's do show run section VRF, and let's jump into VRF definition HR_virtual network, and let's do address family IPv4, and let's do import IPv4 unicast map. We called it global. We're not going to export anything yet. I'm just going to bring it in. Let's do the exact same thing for the other VRFs. VRF definition IT_virtual network, address family IPv4 unicast, actually just IPv4, and import, and exit, and VRF definition IoT_virtual network, rib loop. Well, that's fascinating. I'm going to proceed like that never happened. Oh, you know why? Because it was brought in... No, that shouldn't have been brought in anywhere else. Oh, yeah, it was. Because I advertised it over to Fusion 1, then Fusion 1... No, that Fusion 1 shouldn't have advertised it down. Okay. So maybe something else was happening else somewhere else. But anyways, we're good. Let's do show IP route VRF HR_virtual network. Okay, so now I see that this exists in this particular VRF. That's good. So now what I'm going to do, I'm going to create a static default route for the HR virtual network. And I'm going to say 0.0.0.0.0.0 towards 10.0.122.15. That might work. Now if I do show IP route VRF HR_virtual network, I now have a static route, a valid static route in that particular. It's there. Okay, cool. It's in that particular virtual network. Let's do the rest. IT and IoT. So now if I do show IP route, we can check out IT. It has a valid static route, and IoT has a valid static default route as well. So now what I can do, but wait, there's more. We can go back into BGP 65005. Let's just actually bring up the running config section BGP. I'm going to go into address family IPv4 VRF HR_virtual network. And is this where I can give it a default information originate? Yep. I believe you can also do it on a specific neighbor configuration too, like 140.29 default originate. Let's see if this is on border 2 at this point though. I don't think it will. It might be. Show IP route VRF HR_virtual network. It's not there yet. So let's do this. Default originate. You can also do redistribute static, which we may end up doing. Still nothing here pointing to that. So let's try redistribute static. And There it is. Okay, so that did the trick. So now my default border node is acting as a default border node for the HR virtual network. Yes. Okay, then we can wrap this up by changing address families. Address family, let's do IT virtual network. Default information originate, redistribute static. I'm not going to do it on the neighbor command because I'm just curious. I want to see if this works. Show IP route VRF IT virtual network. Yeah, okay, so we don't need to actually set the neighbor command. You can do it with just the default information originate and then redistribute static. So now we can go to the address family for IoT. Default information originate, redistribute static. Okay. The last thing we need to do now is the exact same thing we did on Fusion 1, which is bringing in those other prefixes from the client networks into Fusion 1 so it knows how to send return traffic in there. So let's do show run section prefix. Will that show? Okay, cool. Yeah, sweet. So let's just grab all of these prefix lists here. Jump back over to Fusion 2, exit out of this, paste in my prefix lists, and create the route maps now. Show run section route. Let's try route map. Yeah, cool. So I'll do HR2 global next. Exit out of that. I'll do. Let's create these just like this. Cool. So now I have the route maps, and now I can perform the route leaks. So let's do show run section VRF. Cool. So I'm just going to grab HR virtual network, and we're going to say the export command right there. VRF definition HR underscore virtual network address family IPv4. Paste in my export command. Exit, exit. VRF definition. Let's go into IT underscore virtual network address family IPv4. And grab that export command. Exit, exit. The last one, VRF definition, IoT underscore virtual network, address family IPv4, and this should be the last command we need to run in order to complete this task. All right, end show IP route, show IP route. So like I said, it takes a little while for these VR. There they are, right there. So we've now successfully leaked all of the routes into the global routing table. We've gotten a default route into each of those VRFs, and our SD access fabric is up and running. So we've done it. And again, if you haven't watched our content on CBT Nuggets, that SD access course, it's a doozy. That is, I have put more effort into that course than anything else I've ever done in my career. That was a labor of love, let me tell you. Very proud of it, and I definitely think like that course will help you get through this and so much more, like actually seeing DNA Center from the front end and actually knowing how to configure ICE for those authentication policies, because that was a whopper too. So that's it. That's been configuring our DNA Center SD Access Fabric challenge completed. Way to go. Made it to the end. So proud of us. So proud of y'all. Again, if you like this stuff, like, comment, subscribe, comment below. Hit me up on Twitter. Let me know what you think. Thanks for stopping by, y'all. I'll see you in the next one.